Okay, so what we are investigating in this video is standard deviation, and we are going to look at an informal way of fully understanding what standard deviation is, because I've taught stats for the past couple of years, and one thing I really noticed in my first year is everybody knows how to calculate standard deviation, or at least use their calculator to calculate standard deviation, but students have a really tough time interpreting and saying and truly understanding the definition of standard deviation. Now, where that comes into play is when you analyze the normal distribution. If you don't fully understand what standard deviation is, you can have trouble understanding parts about the normal distribution. And especially, standard deviation is used throughout stats. It is one thing that basically penetrates every concept in stats. So if you don't completely understand standard deviation, you're never going to understand anything after that. Okay, so to study standard deviation, we're going to look at these two lists, okay? And there's two students, Jim and John, and these are their test scores for the past 5 tests they have taken, okay? And what we want to do is we want to describe the differences between Jim and John, okay? Now, when we look at a list of numbers, one way to kind of summarize a list of numbers is to take the mean, okay, or the average. So if I take the mean of these two lists, they actually both come out to be 75, okay? All right. So on average, they're pretty similar when it comes to ability, we could say, if their mean was both 75. Okay, now, there's one, if you look at these lists closer, there's something that's pretty glaring. There's a glaring difference between Jim and John, and the thing that I would say is John is less consistent than Jim. Jim is very consistent in his test scores. John is a little bit more erratic. Now, in stats, another way we could describe a list is talk about spread. Okay, how spread apart numbers are. All right, now you probably know one measure of spread, and it's a very rudimentary way to measure spread, and that is range. Okay, so range is you just take the biggest number. So if we calculate the range for Jim, we just take the biggest number minus the smallest number, and we get 4. Okay, so the range for Jim is 4, and the range for John is 50. Okay, so there's a big difference, obviously, there. But range is, again, I said rudimentary because we're only looking at or using 2 numbers in the list, and we forget about all these other ones in the middle. So range is good, but there's a more specific way we can measure spread, okay? And that's this idea of standard deviation, all right? So how we're going to analyze this is, and again, I haven't given you a definition for standard deviation yet. That's going to actually come from analyzing the numbers. So I'm going to look at John's numbers first, okay? So I'm going to write them like this, and I'm going to have you do this exercise for Jim too, using the same method, okay? So these are the 5 numbers, and what I'm going to do is I'm going to write the mean of these numbers as 75 up here, okay, above all the other ones, all right? So, and it's just a coincidence that this number is exactly the same as this. So the mean's up here. And what I'm going to do is I'm going to take the distance from each of these points to this average, okay? So how far away are all of these points from the average, okay? So that's going to be pretty easy. And for here, I'm going to use positive numbers. And the reason for that is when we talk about distances, let's say you're talking about the distance from your home to your friend's house, you never say negative. Negative 5 miles away. Doesn't matter what direction you're going to. You're always going to use positive, okay? So that distance is 25, okay, from 50 to 75. From 60 to 75, that's 15. From 75 to 75, that's 0. From 75 to 90 or 90 to 75, that's 15. And then 100 to 75, that's 25, okay? So now we're getting somewhere here. We took a bunch of differences. And again, if I look at these differences, there's 5 of them, okay? So in stats, we want to be able to describe or summarize something quickly and efficiently. So if I go to a friend and say, well, the distance between this is 25, the different distance between this is 15, that's just too much, okay? So I want to give one summary statistic here to describe these differences. Now, what I can do is, and just like we did when we started with these numbers, we can take the average of these distances, okay? So I can take 25 plus 15 plus 0 plus 15 plus 25 and divide by 5. Okay? And when you do that, if you take the average of these distances now, okay, that's basically what standard deviation is, okay? And I'll get to a definition in just a second here, but if I do that, the average comes out to be 16, okay? So what I basically just calculated is standard deviation. Now, there's a formal way to calculate standard deviation, which there's a minor tweak to what we just did, but for now, we're going to say that this is the standard deviation. Okay, now we're going to write a definition for standard deviation, okay, based on what we did. So what we did was we took the distance each data point was from the mean, and we took the average of those, okay? So this is a definition that I use with my students all the time, and I think it's very intuitive, especially after doing this process here, okay? So here's the definition down here. So the standard deviation equals the average distance each number is away from the mean, okay? And that's exactly what we did. Okay. So, and again, this 16 is a summary statistic about how spread apart the numbers are here for John, okay? Now, I want you to pause the video here, and I want you to do the same process for Jim, all right? And after you do that, this process will be written out for Jim, but I want you to do it on your own, and then you'll be able to check your answer, okay? So I want you to find the standard deviation for Jim using the same exact process we just did, okay? Okay, so here's the layout for Jim here. So I have the mean of 75, put it up here, and then I took all the distances, and then I took the average of those distances, and I found that that was 1.2. Okay, so John's standard deviation was 16, and Jim's was 1.2. Okay, so from these numbers here, we can say that John is clearly more spread out, and it's a pretty big difference here. So 16, and this is 1.2. Okay, so again, in stats, we want to be able to summarize things with one single number, okay? And this standard deviation does a really good job of doing that. So again, this is the average distance is 16 for John and then 1.2 for Jim, okay? Now, one more important aspect of this is that there were 5 numbers for each list. You could clearly see that John was more spread out, okay, than Jim. That's pretty obvious, and you probably didn't even have to calculate standard deviation in order to do that. But imagine there's a list of 1 million numbers now, and you want to calculate the standard deviation. You're not going to be able to look at every number and kind of just do a judgment and see which one's more spread apart. Now, where this comes back to, let's say you do have a list of 1 million numbers, I would never want you to do this process, okay? I never make my students do this for, a list of 100 numbers, but this whole process here is to understand standard deviation, okay, at a deeper level, because again, a calculator can calculate standard deviation very easily, but our goal is to truly understand it, because again, this concept penetrates every real concept in stats, okay. The last point I want to make is, this is, again, I said informal. This is a very informal way of understanding standard deviation. It is not the proper way to calculate standard deviation. If you actually look at the formal standard deviation, there's a square root in there, which is a little confusing why that is, but in the next couple of videos, we'll investigate how that formula came about. And honestly, it's really similar to what we did, just some minor tweaks, okay? So hopefully this process here helps you truly understand what standard deviation is, and it, again, helps you interpret standard deviation. That's an important concept, being able to interpret standard deviation, not just calculate it, okay? Because computers can do that for us. Our job is to interpret things in stats.